Good morning and welcome to this Monday, where we are continuing our discussion on optimization. As I am just setting up, getting our problem book ready, can I get confirmation in the chat that you can see and hear me? Whoopsie, put that there. Just get the YouTube chat open here. It's a little slow. Okay, let's get our problem book open. All right, so last time we did problem 10.2 as an example, where the function was given to me, the variables were defined for me. So the first part of the word problem solving steps were done for me. So it's not really a full question in terms of practicing. So let's move on to 10.4 actually, where just words are given making the question and we have to do everything. So that's a little bit more representative of what a test question could be like. You're building a fence to completely enclose part of your backyard for a vegetable garden. You have already purchased material for a fence of length 100 feet. Using that, what is the largest rectangular area that this fence can enclose? So I just realized that, yeah, okay, good. Okay, so let me set up my page here, get something to write on as usual. Let's get this one over here. I don't have my pen ready. Whoopsie. There we go. All right, let's zoom. Zoom. Where's my zoom? Come on, zoom, zoom, zoom. Oh, too much zoom. Too much. That's not enough zoom. There we go. We're looking for 33%. Perfect. All right, so 10.4. So what I always like to do here is visualize with a little diagram just to get my thoughts in order and see what I have and what I'm working with. Not everyone likes it, but it gives me time to just see, okay, what am I working with? I'm working with a rectangular garden. So let's just emphasize that it might not be the same length, right? Rectangle. All right. So I'm going to have to define variables for the length and the width. So let me call this X and that's Y. I'm just planning right now. So the diagram on its own is not a sufficient definition of the variables that I'm going to use. It helps me, but I have to say, let X and Y represent the dimensions of the garden. And then I can point the reader to the diagram as shown, but I need a sentence. The diagram alone is not a definition of a variable, even though I think it is. In terms of the creator of this solution, it's not. You need a sentence at the very least to say, go look at the diagram to help understand which variables I'm going to use. So on the record, I have said this now. You need a sentence. All right. So now I know what X and Y represent. If I look at my question, I have 100-foot long fencing to use. So that means the fence is going to go all the way around. It's going to be the perimeter of the garden. So then what I know, write words, make it easy to read, that two sides for every variable, so 2x plus 2y is going to equal 100, because all the way around the garden is 100 feet of fencing. That is what the question tells me. Then they want to know, what is the largest rectangular area that I can get? So I am interested in area. So I need to define another variable for the area. Now we're going to use the obvious A, but because it's obvious to me doesn't mean it's obvious to everyone. Let A represent the area of the garden. You don't have to write your sentence super detailed, but you need a sentence. Any variable that's going to be used need to be defined before I use it. Then I can say, oh, I'm going to have an area function. And the area is obviously x times y, right? So I have my 4 main problem-solving steps. And if you don't know what they are, go back to the very first lecture. Define the variables. Then step 2 is set up an equation, or in our case, in this kind of question, set up the function. In this case, it's going to be the area function. But now, step 3 is going to be the sort of solving step. In this case, I want to find the maximum area. But if I look at this function, this area function depends on 2 variables. And when I've done my analysis, increasing, decreasing behavior, finding critical points, whatever I want to do, it's always a function of just one variable. So I'm kind of stuck here. And that is where this extra piece of information comes in, that I can solve one of the variables with this equation. And in this case, it's going to be 100 minus 2x over 2, or 50 minus x. And then put that in my function to eliminate one of the variables. So my area function is then going to be a function just of x, which is going to be x times y is replaceable with 50 minus x, and there's my area function. I can simplify that, but I don't really know at this stage necessarily what I'm going to need it for, so it doesn't really matter right now. What matters is I need to have a function of just one variable, because taking the derivative of a function with 2 variables, that's a whole other story, and not a calculus 1 question at all. So now at this stage, so let me number this. I had my number 1 step, define things I'm going to use. That's sort of up to here. Then my second step, come up with a function and maybe clean it up a little bit. Just to illustrate that we are following those 4 main steps. Now at this stage, when I have my function, it might be useful to think, are there any practical restrictions? Because if I look at this function and ask it what its properties are and everything about it, it doesn't know where it comes from. It just says, I'm a function, I'm quadratic, this is what I look like, I continue forever, I'm defined everywhere, great. I have to think about the practical restrictions, the use of this function in the context of the question. So don't overthink it, but there is a limitation on the values of x, of course, right? X can't be negative. I can't have a negative length here. So at the very least, I am going to just say x has to be a positive number. I'm not looking at this too closely and thinking about, oh, how much space do I have for my garden? Certainly not infinitely long, but there's no indication that I can cut it off any further. So just be aware that there are practical restrictions. Don't overthink it, but I am limited to just positive values of x. And I need to be aware of that because in some more difficult situations, maybe I get a critical point with a negative x value. That doesn't mean anything to me for this question. So in more complicated functions, that could very easily happen, and I need to be aware which x values are applicable to the question. Okay, all right. Now we can move on to step 3, where we're actually solving or doing what I need to do. In this case, it's not really solving an equation, it's finding where does this function have a maximum. Now, it's a very simple function. I can verify it by graphing it and whatever, but soon it might not be, and I can't rely on that. So I want to find the critical points. So find critical points of the function, because I know that is where, apart from the endpoints, which I sort of have awareness of, but there's no hard endpoint. I just have to have positive values. We'll get to that in a second. Apart from the ends of the interval, the critical points are the only places where a maximum or minimum can occur. So that's what I need to do. So for that reason, I'm going to take the derivative, and I don't need to see this as a product rule, right? I could just multiply the x in, because I want to have my basic properties, power rule, and those guys. So my derivative is 50 minus 2x. Nothing complicated in this case, of course. Let's start with nice and simple questions. Okay, let's see here. So I do my check for critical points. Let's do it over here. I check where is the derivative 0. Now I do check where is the derivative undefined, but that's not going to be the case here, right, for a polynomial. But I do have to remember that both of them could give me some x values. So for the 0, I might want to, I don't need to, I could just set this equal to 0 and then solve for x. Let's maybe have some space over here, and that is going to give me x equal to 25. So that is the only point that I'm getting out of this. It does fall in my interval, so I want to consider that. And in this simple case, for sure, that's probably where the answer is. But I want to be thorough in my summary here of all things I need to consider, x values, and then area values. Of course, there's no y, that is my y value, so to speak. So what I like to do is put an interval where I don't have an equal sign, right? X can't be 0, then I have no garden. I just want to remind myself that it's not an endpoint I can actually get. I can have a very small x value, but I can't actually get 0 when I don't have an equal there. It's an open interval. You can also write it like this, of course. Open interval, I do need to be aware of the endpoints, because in some complicated cases, the best situation might uh, happen as I get close to this quote unquote end value. It's very rare for us. We're trying to keep things simple. So I put it in brackets to remind myself I can't actually have a 0. but it is the end of my interval. And then I have my 25, which I can actually get. So when I look at the top here, like so, and I look at my function in whatever form, the x times 50 minus x is a convenient one. As x gets closer to 0, as I'm getting to the left side of my practical interval, this first factor is going to make the whole thing approach 0 as well. And I'm looking to find the largest area. So it kind of makes sense that as I reach this extreme, as the length of the rectangle gets really, really small, my area is going to shrink as well. If I just look at the infinity next, if the length of my area gets really, really big, because I have a limited amount of fencing, now I could have made this infinity something else, right? I could have made it 100. But just in concept, as it gets really big, the width of the rectangle is going to shrink down. And I'm going to get something that approaches 0 as well. You could update this. Some people don't like the infinity here. You could have said that, look, let's look at this practically. Let's look at the rectangle. I have two x lengths here. I have this bottom one and this top one. And I only have 100 length for my fence. So if I ignore the y values and pretend they're 0 for a second, the longest x can be is 50. So you can update this, and maybe some people might feel a little bit better about that. So let's do that and put a 50 here. Sometimes I don't really care. Well, sometimes it's easy enough to find a hard number there. But still, I can't really actually have x equal to 50, right? Because then I've used all the fence, and I have no width, so I have no garden. So I still don't have any equal here. But if I look at it this way, maybe it's a little bit easier to wrap your head around. And let's update this guy as well. I still want to have it in brackets because I can't actually get there. But now I can maybe more easily see that if x approaches 50, then this bracket is going to approach 0, and it's going to make the area very small as well. So my best area is not going to sit there. 25 is the only point that's left. My area is going to be 25 times 25. Well, let's throw something on the chat. It's a little quiet in the chat. When I plug it in, it's obviously 625. And looking at all the places where an extreme value can occur, obviously this middle one is my best situation, looking for the largest area. And it's as simple as that. We don't have to, technically, you do have to keep the endpoints in mind, but for our level of questions, it's not going to be a huge deal if you happen to forget it. But in actual realistic situations, they can be very important. So, just a little concluding sentence. The largest area of 625, and that'll be square feet, is obtained for a garden with dimensions, well, I have x. I kind of need to know y as well, right? For that, I can go up here and see, oh, 50 minus x is what y is equivalent to. When x is 25, y is going to be 25 as well. So it's going to be a 25 by 25 square. That is going to give me the maximum area. and you are done. So again, I want to focus on these 4 problem-solving steps. They change with the specific topic, but they're always there. Define your variables. Set up an equation or a function, depending on the situation. In this case, it's a function. Then solve what you need to solve. In this case, we're looking for the largest area. Where that occurs is going to be a critical point. Considering the endpoints, make our table, pick the best one. So it's quite straightforward. And then just wrap things up with a concluding sentence. Nothing that should be overwhelming in terms of the steps you have to go through. Often, what people struggle with is just forgetfulness, I think, and they don't pay enough attention to steps 1 and 2. They just think, well, obviously the area is going to be called A, so I'm just going to use an A. Yes, because we have some repetition, we do get used to using the same letters for certain things, but technically your answer has to stand alone and not assume the reader knows anything. You have to define all those variables. All right. Any questions on this kind of question? So we have sort of a geometric situation where I want to maximize, could be an area. Let's see 10.5 just to be sure. Another garden. Oh, 2 gardens. Oh no. A fence of length 100 feet again is to be used to enclose 2 gardens. One garden is to have a circular shape and the other to be a square. Determine how the fence should be cut so that the sum of the areas inside both gardens is as large as possible. So, similar question, but we are just going to have a couple of different shapes and technically more complicated kind of garden. So let's see what is the same, what is different. The steps are the same. I like to draw a little diagram to plan things out. So I have to have a circular garden and I have to have a square garden. I will need the radius of the circular part and I'll need the side length of the square. So I'm going to start by saying let R represent the radius of the circle and X the side length as shown. I can use my diagram to help define the variables, but it is not sufficient on its own. Now, I might not care about the extra information right now. Maybe they trick me and I don't even need it. Who knows? I'm just focusing on what I need to do. And what I need to do is, again, look at the area of both in this case, and I want this as large as possible. So I'm going to need a name for that function. I'll use an A to represent the total area. Then my function is going to be the area of the circle, which is pi r squared, plus the area of the square, which is x squared. So for this, I do need to remember some basic geometric formulas: area of a circle, area of a square, rectangle, and so on. But by way of our examples, we'll highlight the things that you need to remember. So circle things, area of a circle, circumference of a circle, and they're rectangular things, perimeter, area, square, rectangle, and so on. All right. So now let's look at this function again. I know what I'm going to do ultimately. I want to find critical points, and that's where the maximum is going to sit and so on. But right now the function is not ready for that. Right now the function is a function of two variables. And I don't know how to handle that when it comes to derivatives. So we need some extra information, and that's why they give me the total length of fence, 100 feet. So in this case, if I look at my diagrams, which really help me, how do I calculate the total amount of fencing? It's going to be the perimeter or the circumference of all of this. So the circumference of a circle, 2 pi r, plus the perimeter of the square, 4x, that is going to have to equal 100. I'm going to assume I use all my fencing. So everything's the same in terms of the steps I follow. Everything's just a little bit more complicated because of the shapes involved and the number of them. So now you can decide which variable in this equation do I want to solve and then replace in my function. Some people want to solve for x, some people want to solve for y. It doesn't really matter. Honestly, I don't really put much effort into it. Whichever one I can solve the easiest, I'm going to go with. Maybe R. Doesn't really matter. They're equally simple in this case. Now, I can look if I can simplify this a little bit because it'll make my life easier in the future. And I certainly can divide by 2 everywhere, but the pi is kind of stuck in the denominator. So that is then going to go into my function. And so my simplified function, which is then just a function of x, I have my pi in front here, then r squared. Ooh, that was an ugly 0, I apologize. Let us fix it. 0 minus 2x over pi, that is squared because that's r, plus x squared. Now again, moving forward, I might want to simplify this and clean it up little bits at a time so that it doesn't get too messy or unnecessarily messy when I get to the derivative. So we can definitely do that. I'm going to have a pi times pi at the bottom with 1 pi at the top. We'll leave 1 pi in the bottom, and then a 50 minus 2x, everything squared. And maybe I don't want to put a lot of effort into simplification. Just if I can clean it up in an obvious, straightforward way, then I'll quickly do that so it doesn't get too messy. But there's no real benefit in going crazy with my simplification either. We'll see. Sometimes I want to do something and I go back and see, oh, I kind of want to simplify more. Then I'll do that. At this stage, maybe this is sufficient for me. Now I can think about x again and the practical restrictions on x. Definitely x has to be positive. And at the very least, I have a similar restriction as before, that my x can't be too big because I only have 100 feet of fencing. So maybe you want to put a restriction on like 50 again. If the circle is super small and it turns out that the circular part of the garden is actually not ideal to maximize my area and the circle is gone, then if there's only a square, I have 100 feet of fencing, make it really flat, and I have two x's, one at the top, one at the bottom, splitting the 100, so I can't really do much better than 50, right? Again, I'm not putting a ton of thought into that, but at the very least, I need to be aware that x has to be positive. All right. So let us see. I think I have a good enough function to move on to my derivative, which I need to find the critical points. So let's see what we get. I don't think I've ever done this question. It'd be interesting what the result is. When it's just a rectangle, um, you might guess that the shape that maximizes the area is a square. But now I have a mix. It's not obvious what it's going to be. Let's find out. So now I need to take the derivative here. I'll put the 2 over pi in front, and then 50 minus 2x to the power of 1 times another negative 2 plus 2x. Now we've done these things enough to hopefully be comfortable with the chain rule and all the properties that we're using. But if not, then let me know. All right, is everyone happy with that derivative? Those that are still listening. We have some that are listening. Any questions on that derivative? You have to check. Sometimes I will make a mistake and write something wrong just to check if you are paying attention. So, you never know. And sometimes I could just be thinking of the next question and make a mistake by accident. It happens. Everyone makes mistakes. So definitely check up on me. So now let's simplify this guy a little bit, right? So let's see here. I don't mind my bracket there. I have a negative 4 over pi 50. I'm struggling to make my 50 look good. 50 minus 2x plus a 2x. Let's just leave it like that. You know, I don't want to multiply something in that has a pi and then, it's just going to look messy. And I don't want to do a decimal rounded version of pi either, because that could lead me to mistakes later on. So it doesn't have to look the best. So I do recognize that this is a polynomial, so I only need to check where is this derivative equal to 0. Noticing that though I do need to be aware that a critical point could come from the derivative being undefined. That's never happening in this case. So I only need to set this guy equal to 0. I want to know, what do we get? For some reason right now, I have no idea what the dimensions of those shapes are going to be to maximize the area. I have no intuition at all what that could be. I've never done this before. Interesting. So let me not miss any major steps, because some people are a little rusty on simplification and these little things. I now want to divide by the negative 4 over pi, which means I multiply by the reciprocal. And again, if this is too many steps for you, then I apologize, but let's write it like this. And then a 2 and one of the bottom 2's can cancel. So what do I have here? I have pi over 2x. So then I need to, let's maybe move this guy to the other side to have pi over 2 plus 2x equal to 50. So x is equal to 50 divided by pi over 2 plus 2. And because of the pi, I'm a little stuck. I don't want to have a decimal rounded number there. But now this is my final answer temporarily. So when I present that, I can definitely round that, understanding that if I need to use it further, I need to be as precise as possible. But let's see what that is. All right, 50 divided by some brackets, by divided by 2 plus 2, close the bracket, and we get 14.0025 if I round it to 4 decimal places. Just have to remember that's rounded. Now it might be a final answer, so it's totally fine, or I might need to use it further. And I secretly know I'm going to have to, right? Because I'm eventually going to have to find the matching radius R value. But only if it's actually the best point. So now for most of these, I have a fairly simple situation where there's only one critical point that's coming out of this. I really don't mind, let me just show my function. I really don't mind for our level of question if you ignore endpoints of an interval I can't actually even get. The questions, to be perfectly honest, the questions are going to be set up nicely. So the critical point is where the optimal value occurs. And if I have more than one, yeah, then I need to just compare those two. If there's only one critical point coming out of this, and it falls inside a practical interval, that's going to be the answer. My functions aren't complicated enough to show weird things, and my practical interval isn't very strange either. That if my area is 0, then this is now x. If I look up here maybe, that if I want to see the picture. There we go. If I look at this version, that's the easiest one to sort of reason with. If my radius is small, how should I say it now? If the circle part of my radius, the circle part of my garden rather, is super small, and x is super big, then I just have the x area, which is a square already. If my square dimensions are super small, then I just have the area. And it turns out, because of the critical point, that somewhere in the middle is a balance of the two. Intuitively, I didn't see that it could be at a square length of 14, but it turns out, because I know from functions in general that the best value can only be at a critical point, it's interestingly enough at around 14. I do, however, have to find the corresponding radius. And because these questions are well set up that I can check what happens at 0x and at 0 radius, just to be sure, we'll just finish this first. What's my radius? 50 minus 2x over pi. 50 minus 2x over pi. With this x put in, now you can just put all the decimals in if you don't want all the brackets and nonsense again. Let's see what that is. Oopsie. Equal. I don't need brackets for that though. 50 minus 2 times 14.0024788377889 divided by pi. Let's see what that is. 7.0012. These, of course, feet, right? So these go together. So for a square, roughly 14 by 14, a circle with a radius of 7, I'm going to get an area of, now I have many area functions I could use, right? I could use just the one with an x. I could use the one at the top here, which might be the easiest one, pi r squared and x squared added. So let us do that. Some more calculator stuff when things get a little bit more practical. Let's see what that is. Pi times 7.0012393896165 squared plus 14.0024788377889 squared. Just because you have the option of either putting all the decimals in to your calculation so you're accurate, or you can put these guys in, of course, but I'm too lazy for the brackets right now. My area is 350.0620 square feet. All right, so just so we can get through some more questions here, I'll leave it to you to think about, and let me know if you aren't sure, but at least for the square part, because we've just done one like this. If I look at the two extremes where I don't have a circle, just a square, and I don't have a square, just a circle. If I look at one of them, for example, and I don't have a circle, I just have a square, the maximum, the area is sort of fixed, right? The area is going to be for, well, I have 100 feet all around, 4 side lengths, so 25 by 25 foot square. That's the one extreme. Let's say here, just square. No, we should probably do it right. Just a square. Because it's a square, the area is done. It's 25 by 25. What was that? That area is going to be 625, wasn't it? It was the same as this guy. I didn't even have the rectangle option. I just had the square, 625. But then I see that it's more than the 350 that I get if I split it between a circle and a square. So in this case, this problem is a little bit different. I can, unless they say I have to have, let me just double check. Unless they say I have to have one of each. No, it just says determine how the fence should be cut so that I have as large as possible an area. So it doesn't look like me that I have to have one or the other. I can just have a teeny tiny circle, right? Which is essentially 0. So if I look at this in the extreme case, from a practical side, I can have my radius, of course they have to both be at least 0. Let's do it this way. I'm just thinking about this now. Instead of this restriction over here, I can do them at the very start and say, well, they both have to be greater than or equal to 0, but equal to 0 is okay in this case, because if one of them is equal to 0, then the other one is just going to be taking over. It's not I have just one and I have to have that shape. If 1 equals 0, like the radius, then I have the square left, and that will take all the fence and give me the area in this case 625. If, on the other hand, I have my square side length 0, meaning there's no square, I just have a circle, then the circumference of the circle has to be 100. I'm running out of space here. This is why I'm hesitating. I don't think I have enough space. So let's say here, if r is equal to 0, that means I have just the square and the area is x squared. The circumference restriction is 4x equals 100. That means x is 25. Fixed. There's no function even. That means the area is 25. If my x is 0, then I have just the circle. Then, oh, not 25, sorry, 625, right? 625. If I have just a circle, then my area is pi r squared, with the restriction that 2 pi r equals 100. So r equals, I guess I should find out what r equals, right? 100 divided by 2 divided by pi. It equals 15.9155. And so my area is going to be specific again because I have to use all the fence. It's going to be, let me just write that out, pi times, this is 100 divided by 2 pi. So 100 divided by 2 pi squared. I just don't want to do all the decimals again. So it's going to be 100 squared over 4 pi, because one of the pi's cancel, right? 2 squared, 100 squared, like that. Divided by 4, divided by pi, what do we get? Ooh, we get something very nice. 795.7747. So these are essentially the two endpoint values that I have to compare with this guy. So if I force a mix, then I guess it kind of makes sense. I have a lot of material that I need to sort of have extra, like if we think about these sides over here facing each other, if I have a merged version, then I can cut out some fencing that I don't necessarily need by having a singular shape. The question is just which is going to be bigger, the circle or the square. And the one that maximizes the area over all of these options, the two endpoints, if you will, and the critical point, the circle gives me the biggest area. So we can write our concluding sentence here. The maximum, why is my eye so far away? Maximum area of 795.7747 square feet is obtained when, or let's say with a radius, what was my radius? 15.9155 and no square, only the circle. So in this sense, in this case, the endpoints are easier, in my opinion, if I leave them in the original variables. If I get rid of the radius and just thinking about x when there's a circle, it could be a little confusing. So you could also just think of the restrictions as soon as you define the original function, which usually has a couple of variables in it. It just feels a little bit easier. And then I can look at them separately. There's still only two sides, right? Two endpoints. What do I get for each? What is the critical point? But I'm still comparing all of those to give me the best value. And intuitively, did I know beforehand the circle was going to give me the best area? Not unless I have some experience with this already. By curving those corner points of the square, I guess I'm maximizing getting some extra area. So we have this one kind of question where it's based on a geometrical shape or a couple of them, and we have to maximize some area. It could be a volume as well. I'm just not sure if we have questions like that. Not really. It's gonna That could be a volume. Have a look at the question, at the problems as well. Then the only other variation really is when I bring in some cost. Let's suppose, for example, that the circle has some material that costs a little more than the square, and I want to design it to minimize my cost. That is really the only significant variation that I want to look at. And luckily we have tomorrow in our schedule to have some more examples and just see some variety. But of course, with our examples, we can't cover all the variations. Have a look at the problem book and see just little variations within this main sort of template of problem. And then, as usual, let me know if you have any questions. These problems are a little bigger. Follow the 4 steps. Let those 4 steps guide you slowly through the question. And don't worry about the end if you haven't even done the first few steps. One step at a time, and then it's not that bad. But as always, when you put on a more practical application layer, things do tend to get a little bit more complicated, but we try and contain the difficulty as much as we can. All right. Are there any questions right now that you would like to share? All right, then we will continue this discussion with some more examples tomorrow. Until then.